Friends, I am Professor Shivkumar Balagaon, working as an assistant professor in the Department of Humanities and Sciences, Walchand Institute of Technology, Solapur. In this video lecture, we are going to learn about the concept of Fourier cosine transform with the help of some interesting and important examples. The learning outcome of this topic is students will be able to understand and determine Fourier cosine transform of various functions. So let's see the definition of Fourier cosine transform. Fourier cosine transform of the given function f of x is defined as integral from 0 to infinity f of x into cos lambda x dx. We denote Fourier cosine transform of the given function by the notation capital FC of lambda. Here, lambda is a real or complex parameter. Now we will discuss some examples based on Fourier cosine transform. So the first example is find the Fourier cosine transform of the function which is defined to be 1 for x between 0 and a, and it is defined to be 0 for x greater than a. Note that this is a piecewise defined function. The range of the function is from 0 to infinity, and it is defined differently in the different subintervals of the interval 0 to infinity. Now let's see the solution to this problem. Applying the definition of Fourier cosine transform to the given function, we get fc of lambda is equal to integral from 0 to infinity f of x into cos lambda x dx. Now as we know that the function is piecewise defined function, it is defined to be 1 for x between 0 and a, and it is defined to be 0 for x greater than a. So as per the definition of the function, rewriting the integral, that is expressing this integral as sum of two different integrals, we get fc of lambda is equal to integral from 0 to a f of x cos lambda x dx plus integral from a to infinity f of x cos lambda x dx. Now just putting the value of the function as per the range of the integration. In the first integral, the range of the integration is 0 to a, and in this range the value of the function is 1. And in the second integral, the range of the integration is a to infinity, and value of the function in this range is 0. Just putting the value of the function in the respective ranges of the integrals, we get integral from 0 to a 1 into cos of lambda x dx plus integral from a to infinity 0 into cos of lambda x dx. Simplifying this, we get integral from 0 to a, the product of these two is simply cos of lambda x dx, and because the value of the function is 0 in the second integral, its value becomes 0. So now it simplifies to be, now to evaluate this integral, we need the basic knowledge of integration. The integration of cos of lambda x will be sin lambda x upon lambda, and here the limits of integration are 0 to a, so 0 to a are written here. Now just putting the limits after integration, we get fc of lambda is equal to sin a lambda, because x is a, so sin a lambda upon lambda minus lower limit is 0, so sin 0 is 0, that's why after putting the lower limit we get 0. And finally simplified, and the answer is fc of lambda is equal to sin a lambda upon lambda. So this is all about our first example. Now let's move on to the next example. Second example is find the Fourier cosine transform of f of x is equal to e to the power minus ax where a is positive. Applying the definition of Fourier cosine transform to the given function, we get fc of lambda is equal to integral from 0 to infinity f of x into cos lambda x dx. Now just putting the value of the function, we get fc of lambda is equal to integral from 0 to infinity e to the power minus ax into cos lambda x dx. Now friends, to evaluate this integral, we require one of the very basic and important formula of integration. So I want you people to pause this video for a while and think about which formula of integration is required here. I hope you must have recalled the required formula, and the required formula is integral from e to the power ax cos bx dx is given by e raised to ax upon a square plus b square into a cos bx plus b sin bx plus c. The constant of integration is taken here because this formula is of indefinite integration, and now we are dealing with definite integration. There is no need to write this plus c. So applying this definition in this particular integral, our integral is integral from 0 to infinity e to the power minus ax cos lambda x dx. If you compare this integral with this formula, you can see the role of or the place of a is taken by negative a and the place of b is taken by lambda. So just applying this formula in this particular integral, we get fc of lambda is equal to e to the power minus ax upon minus a whole square plus lambda square into minus of a into cos lambda x plus lambda into sin lambda x, and the limits of the integration are 0 to infinity. Now note that the value of a is given to be positive, and when we put the upper limit infinity, it becomes e to the power negative infinity, and we all know that e to the power negative infinity is 0. Therefore, putting the upper limit, we get the answer as 0, and putting the lower limit is 0, so e to the power 0 will be 1. So we get 1 upon a square plus lambda square into minus a into 1, because this one we have written because cos 0 is 1, and here we have written 0 because sin 0 will be 0. And after simplifying, we get the answer as a upon, see, minus into minus plus, a into 1 is a upon a square plus lambda square. This is all about our second example. Now moving on to the next example, example number 3. Find the Fourier cosine transform of f of x equal to cos x for 0 less than x less than a, and it is equal to 0 for x greater than a. When you look at this problem, you will understand that here the function given to us is again a piecewise defined function. Function defined to be cos x for x between 0 and a, and it is defined to be 0 when x becomes greater than a. Now let's go to the solution to this problem. Applying the definition of Fourier cosine transform to the given function, we get fc of lambda is equal to integral from 0 to infinity f of x cos lambda x dx. Now just writing this integral depending on the definition of the function, we get fc of lambda is equal to integral from 0 to a f of x cos lambda x dx plus integral from a to infinity f of x cos lambda x dx. So now in the respective range of the integration, we will have to substitute the value of the function as per the definition. So doing that, we get fc of lambda is equal to integral from 0 to a, and in this range the value of the function is cos x. So integral from 0 to a cos x cos lambda x dx plus integral from a to infinity 0 into cos lambda x dx, because the value of the function in this range a to infinity is 0. Now simplifying, we get fc of lambda is equal to integral from 0 to a cos x cos lambda x dx plus the value of the second integral will be 0. Okay, so now here the simple adjustment is made in order to evaluate this integral, that is multiplied and divided by 2. fc of lambda is equal to 1 by 2 into integral from 0 to a 2 cos x into cos lambda x dx. Dear friends, here evaluation of this integral directly is not possible. That's why we need to separate this product cos x and cos lambda x by using one of the appropriate trigonometric formulae. So we need to recall that formula. Do you know what is the formula? 2 cos A into cos B. Please recall it. Because that formula we need to apply in order to evaluate this integral. So recalling that trigonometric formula, that is 2 cos A into cos B is equal to cos of A plus B plus cos of A minus B. We are going to apply this formula here in this integral. So if you compare this LHS 2 cos A cos B with our integrand, that is 2 cos x into cos lambda x, we can easily understand that the value of capital A is x, whereas the value of capital B is lambda x. So applying this formula in the above integral, we get fc of lambda is equal to 1 by 2 times integral from 0 to a cos of 1 plus lambda bracket complete x plus cos of 1 minus lambda bracket complete x into dx. So this this step is written on the basis of this formula. Especially this, look at this RHS, that is cos of A plus B plus cos of A minus B. Here A is x and B is lambda x. So now just simplifying, that is separating these two terms with the help of this integral, we get, and integrating them, we get fc of lambda is equal to 1 upon 2 into integration of cos of 1 plus lambda x, 1 plus lambda bracket complete x is sine of 1 plus lambda bracket complete x upon 1 plus lambda plus the integration of this term cos of 1 minus lambda x is sine of 1 minus lambda bracket complete x upon 1 minus lambda. The limits are 0 to a. Now applying the limits, we get, putting the upper limit, we get 1 upon 2 into sine of a into 1 plus lambda upon 1 plus lambda plus sine of a into 1 minus lambda upon 1 minus lambda. And we get 0 as our answer when we put the lower limit because of the sine terms. Because when we put x equal to 0, sine 0 becomes 0. So that's all about our example number 3. So this video lecture is prepared with the help of reference books Higher Engineering Mathematics by B.S. Grewal and Higher Engineering Mathematics by B.V. Ramana. Thank you very much, friends.